I just want to thank everybody for being here today. Today we have a speaker from far, far away, New Zealand. We're super excited to have him. This is David Brebner from Umajin. We'll go ahead and let him get started.
Awesome. Hello, everyone. How do I click forward? Look at that. All right. I guess perfect. Thanks, dear. So the key three categories we look for, and I think it was covered a bit in the previous presentations, when there's a subject that makes sense to teach in this manner, are subjects that are difficult to set up or difficult to achieve, expensive to set up, or dangerous to train. So, for example, if you're teaching how to use a fire hose, that's probably a bad choice. If you're teaching how to use a hazmat suit, that's much better because that's much harder and much more dangerous to train with. We're going to talk a bit about the work that's been inspired by the world-class manufacturing facility. So this is a pretty amazing facility where they train new workers and they retrain existing workers on new equipment. They've got a pretty important, sort of approach to this training. So you're trying to engage people and make them part of the process, and I think that's really important. This is systematic. You want people to be able to repeat and do the same thing, but they've got to do it in a way that's not just safe for them, but safe for everybody else. And that's quite a consideration when you think about it. These mechanical motions you're making, the sort of level of decisions you have to make, you have to try and do things that can be accomplished by everybody in a repeatable way that's efficient, safe, and gives you the best quality outcomes. So what we're looking to do is not something that's just here as a process or here as a multi-choice quiz, but to literally put multiple people at the same time, because these are not jobs done by one person, into a procedural simulation and to let them explore those deeper concepts. And the idea is that the VR isn't just a one and done experience, that it's part of the learning process. So during the day, you will go in and out of the VR experience. Different parts of the group will try it, and you'll all, as a group, discuss what's going on and what the outcomes are and what you could do better next time you try. And the simulation will actually allow you to, when you retry it with those changes, you'll be able to measure and see the quantitative results of those changes. It's a real challenge, like I mentioned, teaching the difference between quality, safety, and efficiency. Sometimes they're the same thing, and you can make something safer, faster, and better, and sometimes they're the exact opposite of each other. So it's a real challenge finding the right safety precautions or the right procedures or the right tools to make a given job better and more efficient. It's also a real challenge when you have potentially 4 people, sometimes even 8 people working on a given task. So when you have to put a high liner inside a car, which is the roof lining, you need 4 people, 1 on each corner, and you need to position yourselves around the car and slide it in, and you need hood protectors and a whole range of different steps to make that process possible. So going through these kind of complex ideas with 4 people just adds a whole level of complexity. And the great thing about this system is because it tracks everybody's precise motion inside the volume, we get all of their range of motion data, where they've walked, what they're doing. It also allows you to repeat it, as I say, quantifiably. So one of the challenges, where are the tools for helping create this new generation of technologies? So I'm here with, obviously, with Umajin, and we've got our own U engine. It's not Unreal or Unity, it's Umajin, and the goal there is to sort of supply a scene scale simulation that's able to ingest data from Omniverse connectors, so we can bring in the actual live production CAD data and have people doing their training and doing their simulation, whether it be aerospace or automotive, using that live data. We also work with phase space to do the tracking, so these little red LEDs track to about 1 millimeter or a 32nd of an inch in an XY volume at, in this case, 240 hertz. So it's very, very fast, and that's really important. If someone's holding a tool, like a power tool, and they're trying to work together on a task, so a physical prop, and they want to pass it to one of their teammates, they need to know their hands where it looks like it is. So you can literally collaborate together, no problems. This is sort of the pipeline we're using at the moment, which is making a big difference because this can pull in the latest revision of any of the parts in a given vehicle. And if you're teaching someone, for example, the challenge when you're trying to fit, and this is something that people do much better than robots, is where you've got, for example, 1 million possible variations, which sounds like a lot, but once you add trim and exhaust type and a bunch of other factors, those multiply out very quickly. And you need the latest version of that trim, you need the latest version of those different parts so you can see the combinatorial problem that occurs. We're using Airlink, which has proved to be very successful. So this is with the Quest 2 you saw. And the benefit there is that we can use NVIDIA RTX enabled laptops to render, in some cases, 800 million polygon CAD models and get those to the headset with very low latency. And it's really important that fidelity's there because people are literally reaching in, grabbing parts, manipulating them with their hands. So you need to have a one-to-one relationship between the actual vehicle that they're used to working on, because often these are very experienced workers. These are people who have been in the plant, have been part of the development process. So, and then the high fidelity rendering, so the ability to share all this information with PBR materials, very high polygons. Shadows are actually really important. They give people a sense of where something is in the volume, and then with the real-time motion capture. We're using the hand pose, which is really cool. So this is powered by the Qualcomm chipset and some of the AI there with the front-facing cameras. And I think I've got a sample of it here. And it's very compelling. I mean, it really does look like you're working with someone else in 3D, and it's amazing how much in a workspace where it's very loud, people speak with their hands. And I know that sounds odd, but it is absolutely how it works in the factory. And then we have the XR editor. So this enables our designers or the design teams within the training groups to be able to grab assets, move them around. Remembering everything's at one-to-one scale. Everything is literally real-world size, and you're building your XR scene to fit inside the volume of your training space. So it's quite a different thing from the world building you might see in Unity and Unreal. You also have to have a flat ground plane because that's what people are walking on, and you need to be able to clearly set the boundaries where people can and can't walk. And it's a pretty fun experience, and it's within this interface, which I'll show you here. You can just hit the XR view and you can view this immediately in real time in your headset as you're grabbing and manipulating items in your scene. And you can organize, in this case, these are all virtual props, but you can have physical props. So you attach an anchor to the physical prop with a tracker on it, and then you can have a VR proxy or an AR proxy, in which case you're bringing up metadata. Where you can literally take a physical prop, you pick it up, you pass it to somebody, it shows up in the VR rendered scene. And in the case of augmented reality, that's really important because what we do is we put you can think of the tip of the tool, for example, would have an active element, and when you take that torque wrench, you can apply it to a virtual bolt, and the physical tool you're holding will actually have an action on the real world, and you have to be using the right torque wrench, for example, to complete that task. And this sort of goes into the interaction types. So this is probably the biggest part of the system, and it's really how you sort of define the experience that users are going to have. And some of these are quite complex to achieve under the hood, but we try and make them very easy to use. So, for example, hand triggers is sort of the initial starting point where most simulations begin. So that's the ability to configure a region or a part that when you place your hand inside that region, it's going to cause something to happen. So it might play an animation, might play a sound, might cause the system to reconfigure, might take you down a different branch in the simulation. And that sounds simple, but then you've got to consider things like maybe you have to leave your hand in that space for a certain length of time. And it can certainly, even though it's the simplest trigger, it can result in some very sophisticated simulations. We've got the multi-hand triggers, so this is where you're required to use two hands to do a job, and you might have specific hands needing to be placed in specific spots. Those hands may be interchangeable, and that can really vary depending on the type of part you're dealing with. And then within that, we can actually check for the body posture. So we can mark you down, for example, if you reach out and reach away from your body, because we're tracking the head, so we know where the rest of your torso and your body is placed. Finger triggers are really interesting. So with the finger triggers, you can point and touch things specifically with individual fingers, or you can require people to place fingers in certain positions or orientations. You can look at the way people make a grip on a tool, which can be very, very important when you're using a tool 8 hours a day, many days in a row. And particularly with some of these tools are very carefully calibrated. So for example, there are $20,000 torque wrenches, believe it or not, and you need to treat those things with a lot of care, and they're precision equipment that allows you to configure very precise pieces inside a vehicle. And the way you use it, the way you hold it, the angle you hold it, all of those things are very important to being able to use them successfully and efficiently. And also the failure of not correctly attaching some of those fixtures is severe. So you definitely don't want parts of your engine falling apart, for example. We've got head triggers. So this is a really interesting one. So as people move around the space, perhaps they're moving around if the vehicle's raised up and they're moving around, it'll essentially tell them different information depending on where they are in the vehicle or where they are under the vehicle. And some tasks can't be completed unless they're standing in the right spot. Look at triggers. So this is a really important one. This is particularly where you have maybe safety protocols in place. So for example, if you're doing a traffic stop for a police officer, there might be a requirement that they look at the number plate and then they call it in using their radio. So we can actually make sure that people are citing and checking different safety factors before they continue with their process. We've got voice triggers, so it has the ability to have conversations with generative AI. But a lot of the time it's really simple. It's just, maybe there's some verbal communication required to complete a task, and you're just checking to make sure people are following the process and checking and saying, is this okay, can I proceed? There's prop triggers. So for example, that a screwdriver, torque wrench there on the table, when you pick that up, only that tool can be used to complete certain tasks. We have hand pose triggers, so that's sort of similar to the finger triggers. We can actually track the shape of the hand and what the hand is doing, and that can be particularly useful where you don't have a tool involved, you're just making sure people are picking things up the right way. Multi-person lifting, so I think I mentioned that you can have up to 4 people lifting a highliner, which is pretty intense. And then we have a whole set of process timers. Process steps. So these are timers and counters, order of operation, task validation, the aforementioned multiple agent tasks, which, if you're doing things like with pipes and welding and fitting, fault diagnosis, gamification and scoring. And that last one's actually turned out to be really useful, because that is a great icebreaker for groups of people. So if you're doing a day's training and you've got a series of chances and you're trying to compete with everyone else to do the best on quality and efficiency, that gets 18-year-olds motivated. So that's always nice in a training session to have people engaged and enjoying what they're doing. This is a bit of a sort of a show reel. So this is the editor with some of the updated CAD data. These are 2 people working together. So this is showing the communication with your hands, which I know it sounds crazy, but this is literally how it works when you've got a lot of noise going on. So they're able to, clearly indicate to each other their current status. He's not wearing his safety glasses. That one's complete. So there we go. And then from the perspective of the sort of the key benefits, what we've been able to provide is these extremely realistic virtual environments. So I think that can't be understated, how important it is to not see an artist's rendition, but to be able to render these very high fidelity CAD models. These are the parts that people are going to be working with on a daily basis. Vehicles are extremely complicated, whether they be airplanes or automotive. There are a lot of parts, a lot of stuff going on, and people don't just do one job. They'll move around the plant and they'll have experienced what's going on. So having them able to work on the real stuff makes a massive difference. We wouldn't be able to do this, particularly in VR. There are, as I mentioned, AR versions we're prototyping at the moment, but in VR, the face-based system's been critical to achieving that ability to have safety. And we're also working with the Quest Pro, and that has the benefit that because of the pancake lenses, you don't need to hood the eyes. That does break a little bit of the am I really in this new world? But it has the massive benefit that you can see your feet. And I know once again that sounds like a small thing, but when you have 4 to 8 people moving around inside a training space, knowing that no one's going to trip over and fall into somebody else is very beneficial. The ability to have physics, so things will actually act with inertia. So when you're using the multi-lift, it's like you have elastic connected to your hands. You can't drag things faster than you would want. If you're not lifting the right way, you won't be able to lift your side. The ability to have actual physics, so actual props, actual car chassis that people are working on. It's actually very it's crazy, to be honest, because it's like you've got this amazing haptic feedback, but it's because it's your real hand reaching out and picking up a real tool and pulling a real trigger. So those triggers, for example, are instrumented, they pass it back, and that will cause the action to occur inside the simulation. And if you think of what that sort of means, all the welding animation, maybe it could be involving areas where you'd need respirators. We can simulate things that would be, once again, difficult or dangerous to have people doing. Working with that KUKA robot that I showed, for example, it would never be just freely standing out there. Those things have enough torque to throw someone probably about 30 feet. So you don't want to be hit by one of those robots. They're normally all enclosed in a cage, and there's a whole training module which just teaches people how to interact and how they can engage with a robot, because often there's manual processes that have to be done. They have to present the part at the cage ready for the robot to act on that part before they can then take that completed sub-assembly and bring it back into the line. So that ability to mix these items together is really, really important. I think the idea of the muscle memory, or at least the ability to repeat scenarios but without any problem, let's try again. One of the other really interesting things is that there's live variation in there. So the trainer can throw a spanner in the works, so they can mess things up. They could maybe change the state of something, they could introduce a fault, and they can do that at any time. So someone might be there trying to compete and get the fastest score. They've just done it 4 times in a row. The trainer introduces a variation because they want to, have that person a little bit caught off guard and see how they handle that situation. So that's a really that really brings the training to life, and it involves this relationship that the trainer has. This could be a 6-month course, for example. So your students, you've got a student who's performing well, you want to see if you can catch them out. So. And then in terms of the result tracking, which we've talked about a few times, I think that's really important as well. So their posture, their progress, their speed, a whole range of basically performance metrics are recorded, and those are directly displayed to the user in the class. And I think it's a big difference between, hey, you did that task and you took that bolt, to, hey, look, it took you 12 steps and you had to pick it up from over here. What if we moved the torque wrench closer? So as a group, they'll all discuss it. The trainer can then alter the scenario, you rerun it, and you see that you're able to do it not only faster but more efficiently. So that ability to do that as a group is really important. Excellent. Ready for some questions?
So does anybody have any questions? That was so good. I really enjoyed it. Do we have any questions in the audience? Awesome.
Hi, Michael Hyatt with Northrop Grumman. Great presentation, thank you. I was wondering if as trainees get trained, do you see a diminishing return on learning, like when they get used to the process, or do you see a pretty steady return on investment?
I think what's particularly exciting is that they've not been trying to train specific processes, because processes can change so fast, and they're not even necessarily trying to train specific skills. So even though I mentioned installing a highliner, that's really just the subject matter for the concept of teaching people about these challenges. And sometimes your most experienced staff are your most resistant to new processes. And one of the challenges, as I'm sure you're aware, is there's just so much changing with, additive manufacturing and die casting, and in the automotive space, electric vehicles. So you need people who, even though they are experts in their own field, to buy into the idea that they should be supplying ideas for quality, efficiency, and safety, and that those ideas are being talked about, considered, that they can be part of that process, that they're all valuable, but that the reason they may not be implemented is because, here's the process we've come up with, that we've engineered, that's going to work for everybody, because we all want to be following the same process. And I think it's exciting to be doing training that sort of has a life beyond, I'm going to install this one particular unit, and you're teaching people to learn these processes forever. And then the idea that there's a new thing being introduced, so we're getting robots and humans interacting directly, so rather than it going into the welding bay and you just leave it and it goes through the welding process with the robots, now you're actually having these interactive sessions. And so while exactly what that task might vary, you're teaching people the critical skills and what do I do when things go wrong. You're really getting people up to speed with how to deal with those situations.
Hi, Cameron Craig here. I'm also with Northrop Grumman. What's the software's competitive edge compared to other VR training softwares currently available?
I think the key thing is we've designed it to be room scale. So we're able to bring across the high quality assets in real time. So we have Omniverse integration, but we can bring data in from all kinds of sources as well. And then the big thing is the tight integration with the optical tracking and the multi-person, so up to 8 people in the same volume with precise positioning. And then probably the most important piece is the easy-to-use tools. So we've got a low-code editor, and the great thing about that is it includes a full development environment. So you could build physics simulations, you could have JavaScript that drives behavior of simulations inside the experience. So you could have fluid dynamics. And then you can also integrate with external APIs. So for example, this is pushing directly into an LMS in the case of some of the automotive players. So that ability to sort of go beyond just the kind of a pre-canned experience and make it a proper application that just happens to be manifest on a headset. We do actually have a number of customers who ended up doing training in the aerospace industry just using tablets. So they actually have those on site and they use them as reference guides. So it's very flexible in the way you can deploy it, but it is really aiming for that, room scale.
Awesome. I don't know about you guys, but I'm sold. Do we have time for one more question? Are there any more questions in the audience? All right. Well, can you let the audience know how we can get in contact with you?
Yep, absolutely. You can add me on LinkedIn and umajin.com.
Thank you, David.
Awesome.
Awesome. Have a great day.